All right, now what we want to do now is finally go through the other way the other transformation that you can do with sine and cos. We've already looked at changing the amplitude, changing the period, and changing the phase shift. So we look at how you can change the vertical orientation of the graph, and then we'll put it all together in a single little package and a way to remember it all. So let's have a look at what we've got here. Vertical shift. So we've got y, let's just look at our y equals, and so we want to do y equals 3, well we've been using 3 a bit, haven't we? So let's just use 2. Y equals 2 sine x plus 3. Okay. This we know is the amplitude, and you can see that there's no period change. This is the way you move the graph vertically. So positive means we go up, negative means we go down. So if you've got a constant at the end there, it just moves the graph up and down. So it's probably good when we go to sketch these to do it in steps. And we'll just start off with a y equals 2 sine x. Now 2 sine x will go between plus 2 and minus 2. We might have to put our, make it go up in 2s. So that's 2 minus 2. And that'll be 4. And that'll be 6. Okay. So if we've got 2 sine x, it's going to oscillate between plus 2 and minus 2, and it's going to go out. So we do our 4, and then we go halfway. So if we're working in radians, so this will be pi, 2 pi, pi on 2, 3 pi on 2, and 2 sine x will go bang, bang, it starts there, goes down and comes back up. So that's our y equals 2 sine x. Now plus 3 moves the whole graph 3 units up. Okay, now sometimes it's a bit difficult to get this concept, but what we're going to do is, if you think of the middle line, sometimes called the equilibrium line, because the graph oscillates up and below the equilibrium line. The equilibrium line at the moment is just the x-axis. So in order to draw this, it's sometimes better to just think where the equilibrium line is. Plus 3 is going to move the equilibrium line up 3. So that's 2, so 3 is going to be here. It's going to move it up there. So my new graph of y equals 2 sine x plus 3 is going to oscillate above and below that line. These 4 key points that we always plot, they are going to be exactly straight up from where they are on the x-axis. So those 4 points are there, and then it's got a amplitude of 2, so if that is 3, it's going to be 5, so it's going to go, and once again it could help you just to dot some lines above and below 2 units. So there's 3, that's my equilibrium line. It's going to be 5, and if you take 2 off there, we're going to get back to 1. So there's my other minimum value of the sine graph. Now I can actually plot. So this one goes up 3 units, this one goes up 3 units, this one here goes up, this one here goes up to there, or that one there goes up to there, and this point here goes up to there. So you can see what effect the plus 3 has. It has moved the entire graph 3 units up the y-axis. So here's my y and here's my x. So there's the graph of y equals 2 sine x, amplitude of 2. This has still got an amplitude of 2 because the difference from a peak, which is 5, to a trough is 1. So that's 4. and you divide it by 2 always, so it still has an amplitude of 2, and the whole graph has been moved up 3 units. Now if it was -3, you'd have to go down this way. Okay, so that's vertical shift. Now putting it all together, we're only interested here in sine and cos. There is a tan graph, but we'll leave that for future courses. So just remember this: if you've got y equals a sine b outside of x plus c plus d, or if we've got a cos graph, a cos b outside of x plus c plus d. Okay, now what do each of those letters mean? A is the amplitude. Don't forget, that's always positive. Amplitude is always positive, but A can have a negative value. You can have a negative out the front there, but the negative simply flips the graph. It's not the amplitude. Always positive, so don't ever say the amplitude is negative. B gives us the period. B isn't the period. The period is equal to 2 pi divided by B if you're in radians, or 360 divided by B. So whatever the number is there, just put it over 2 pi, put 2 pi over it, or 360 divided by that value, and that will give you the period. C is the phase shift, sometimes called the horizontal. Because it moves it sideways. If it is positive, if C is positive, you move to the left. If it is negative, you move to the right. And the last thing is what effect this D has. It is the vertical shift. Once again, if it is positive, move up, and it is negative, move down. Okay, so you're going to, we'll come back in the future videos and just talk about and do some examples showing how all that works, but that's what you need to memorize. You need to remember all what A, B, C, D tell you about the graph. And that's a matter of, just like we've done here, is to start with a basic graph and then just go through the different steps. And it may be good to do the initial stages in dotted lines and then do the final in a heavy line, or do different colors or something like that, just so that you know which one is the final graph. But that's the general transformation of your basic sine and cos graph, what each A, B, C, D do, and you need to be familiar with how they work.